When you build a modern bridge, the stakes are measured in tons of concrete, thousands of steel beams, and massive physical stress. To make sure these structures stay standing, civil engineers rely on a specific calculation known as the factor of safety. Blueprints often fail to predict the chaos of the real world, the convoys of overloaded commercial trucks, or the drivers pushing speed limits through a storm. This diagram shows exactly how that margin is applied. You have a structural pillar required to hold a baseline weight of 10 tons. Instead of stopping there, the pillar is intentionally engineered to carry double or triple that load. Adding this extra padding is universally accepted as good engineering. It protects us from cheap materials and basic human error. But it inherently raises a rather dangerous question. At what point does a healthy safety margin become too much margin? Imagine a completely fictional, majestic marble monument. Tourists walk up to these massive, monolithic stone walls and oversized columns, and they admire the breathtaking engineering. But if we strip away the romance and look at the strict physics, those walls only needed to be a tiny fraction of that thickness to stay upright. The reality of the monument is comically overbuilt. Is the structure safe? Absolutely. It is never going to fall down. But it also represents an astronomical waste of raw material, expensive labor, and construction time. This point of diminishing returns is exactly where professional civil engineers stop admiring the architecture and start running cost calculations in spreadsheets. Engineering brilliance is found in fitness for purpose. It is the discipline to provide the necessary strength without wasting a single dollar on excess material. Let's take that exact physical flaw and bring it into the digital world. Picture an incredibly basic software requirement, an internal company dashboard. The target audience is exactly 100 employees. A system built for 100 users looks exactly like this diagram. One single user connects to a standard web server, which talks directly to one database. Yet, faced with this tiny task, development teams will immediately demand heavy, buzzword-laden architectures like Kubernetes and microservices. Almost overnight, the simple dashboard is suffocated by Kafka clusters, service meshes, and complex event-driven layers that nobody asked for. In civil engineering, every extra pillar costs $500,000. In software, adding a global message queue is just a few clicks in a cloud console. This lack of physical friction creates a unique trap. Without the immediate cost of concrete and steel to slow us down, developers often lose their sense of scale entirely, building digital fortresses for tasks that only require a simple shed. Now, to be fair, distributed systems and container orchestration tools are genuinely incredibly powerful technologies. They solve massive problems for massive companies. But the core hidden cost of all software is that complexity has rent. Every single advanced, free tool you add to your stack extracts an ongoing physical toll from the team forced to maintain it. You pay this rent in highly specific ways. You pay it in endless debugging sessions spanning 10 different microservices. You pay it in broken deployments, confusing ownership arguments, and constant, agonizing alignment meetings. Teams find themselves fighting massive, enterprise-level infrastructure fires before 5 actual users have even logged in after lunch. Prematurely adopting enterprise-scale tools does not future-proof your application. It actively creates a miserable operational environment and guarantees massive technical debt on day one. The lean approach for a 100-user app is exactly what we started with, a simple web app paired with a basic database. When demand grows, take proportionate steps. For 1,000 users, you upgrade the database capacity or neatly slide in a simple caching layer. This disciplined, step-by-step evolution sits in direct contrast to the industry's toxic instinct, which is to build Netflix-level infrastructure right out of the gate. Safely building for tomorrow requires solving today's actual scale with total precision. You cannot suffocate the current project under the speculative, heavy weight of millions of imaginary future users. Going back to our civil engineers, they inherently understand the golden rule of scale. You do not build a quiet suburban house using massive concrete fortress walls, and you shouldn't treat a tiny internal dashboard like a planetary data platform. That pursuit of clean engineering, without the unnecessary drama or bloat, is the entire philosophy behind Factor of Safety 1. Because when we apply overly powerful systems to incredibly soft, simple problems, we look ridiculous. It is exactly like firing up a heavy-duty, gas-powered chainsaw just to slice a stick of butter. Ultimate architectural success is boring. It means deploying the exact right tool for the exact right problem, carrying absolutely zero extra baggage. Anyone can bolt together 20 massive technologies and call it an architecture. But true engineering judgment is knowing exactly when to stop building.